Welcome back to another Let's Code. Today we're going to be working on a CLI application in Rust that will get us the weather and air quality for any given place that we are. So the air quality API that we're going to use is aqicn.org/API. If you don't have a token and you want to follow along, you need to click on this link and then fill out this form. They will send you an email at which point you will get a token. So for this project, I'm just going to start a new cargo project called AQI. AQI is going to be our binary name. So if I go into AQI and I open up a VS Code instance, VS Code wants to update. Yay. That's exactly what we want. No, we're going to hit later. So we have a cargo application. We have a cargo toml. We have a main.rs. The main.rs is our binary. The cargo toml is any dependencies that we'll have or anything like that. I know of a bunch that I want right off the bat. So we've got color-eyre, which will handle all of our error handling for our CLI app. StructOpt is going to do argument parsing and things like that. Request is going to be the thing that we use to call out to the API to get the request back or get the data back. Saturday and Saturday JSON are going to be the deserialization or serialization stuff that we use to parse the JSON from the API into Rust stuff. And then Tokio is going to be the async runtime that we use to allow request to be an async library, which it doesn't have to be because request can be blocking as well, which actually I covered in a simpler version of this weather CLI. So if you're interested in that, rustadventure.dev, sign up for the email course at the bottom, and you will get a run through of the simpler Rust weather CLI. Uses the same API, just explains sort of like as an intro to Rust and Rust features. So let's see, if I remember correctly, code config path will give me my new shell config. Perfect. I need to set my API key in here because I'm using new shell. If you're not using new shell, you'll be fine. You don't need to set it. I just don't have a way to revoke this key, so I'm not going to show it to you. I'm going to name it AQI token. Cool. So I have it set in my environment variable now. I just need to remember that I called it AQI token when we use it later. So let's get into it. So the first thing we're going to do is Tokio main, which Rust Analyzer has identified a problem with. The problem actually is that we didn't ask for the ability to do that in here. So Cargo has a feature called features, which I've talked about before. And we can just do features equals, I think it's macros for Tokio. Yeah, it looks like macros. So we should be able to cargo build. And this will download all of our dependencies and stuff. So that's going to take a second. In the meantime, we'll keep going. And if I've made a mistake, then Rust will tell me in a little bit. So we are going to want some stuff from color-eyre. And one of those things is air. And I think result is top level. So we're going to make this into a result of unit so that we can do some error reporting and handling from our CLI. I'm using color-eyre and not something else because it is, okay. So async function here needs to have, or Tokio main needs an async function to turn into our main function. So that's one of the reasons our build just failed. Did I mess something up? The default runtime flavor is multi-thread, but the RT multi-thread feature is disabled. Okay, so I need to re-enable one of the, we're going to go with all for Tokio right now. Does it not have all? Tokio doesn't have all. Tokio.rs is the runtime stuff. I don't really want the API docs. Full is the thing that I wanted. Full is the thing that will just let me like do stuff. And then we can take it back down later if we want to. One of the things that we need is macros, which will let us use this macro. We also need runtimes and stuff like that. But full is fine for us for now. In the end, all it will mean is that we have a slightly bigger CLI in the end than we wanted, but it doesn't really matter that much. Expected result found unit. So we need an OK unit here because we do need to return this unit type for the result. Result is either OK unit or it's an error with an error. Error will help us construct those errors later. So yeah, so if we cargo run now, we get hello world. We're not doing any async stuff yet. We just have the runtime running. We're not doing any error handling yet or anything like that. So if we do like this instead, it's not returning this because Rust is an expression-based language and I had something else there. So I would need to wrap this in err, ERR. ERR and air, EYRE sound way too similar. Is that not the macro? Is it err? I thought error, the macro was the top level, but apparently it's not. It's error. So you can see over here on the left that we've got hello world and location, whatever. We haven't initialized error yet. So we're going to do color-eyre install. And that's actually going to have the potential to fail. So we'll handle it with the question mark, which will pop it back up to the result. And now we get actual colors here and a little bit more reporting. You'll see that before we actually installed color-eyre, we were getting kind of like this bland error. That just had like a location of the file says, or the location in the file and stuff like that. And now it has this nice red, like, hello world, and where it went wrong. And we can add more context to this, which is really nice. So we'll do some of that later. Let's see. What do we need to do here? We need to set up our CLI next, I think. Maybe. Let's make a request first. Let's get rid of this. Let's bring this back. Let's set up a new request client. So let client equals request client new, because we don't need anything special. Yeah, and we just get a client back from that. And we're just going to use a get here. So get, and then I don't remember the URL, so I need to go find the URL. I have found the URL. To make this a little bit bigger, this will pop onto the next line after we keep going here. I believe we just .send here, if I remember correctly. And this is going to be async, so we'll await it with the question mark. And if anything goes wrong, that error will pop back up, and we'll get it here, just like we get this error. If not, we won't. Let's debug response to make sure that we're getting something here. I don't remember if we need to deserialize this or not. Apparently we don't. Scheme, HTTPS, response, URL, headers, AQI, path. So we do need to do so let's check out the error that we get here actually. So we have a response struct on the left, right? So it's not actually just like random stuff. This is actually a type from the request crate. So it's a struct that has, say, like a URL field and a URL struct inside of it. And this is like the request as we, or the response, I guess, as we got it back. So if we try to run this, the response.json method is not found in response. That doesn't feel right. Let me check the request docs. We'll go request rest. We'll go to the docs.rs link. You can see up here, docs.rs. So this has .text. Did I put it in the wrong spot? I think I put it in the wrong spot. So get send await, and then I would expect .json to be here, and they're awaiting on the text. So I'll do that here too. But it says that .json doesn't exist, and I think it's gonna do that again. So what did I do wrong? Did I not import something? Post JSON, posting JSON, fetching JSON. Let's look at client because I did something wrong. So that gives us a request builder. The request builder .send is what we're using, right? Create feature JSON only. That might be important. Too concerned about it yet. So send gives us a response. A response is the type that we just saw, which means that if we scroll down here, we see text right here. Text with car set. Yeah, okay. So they moved JSON to a create feature. And you can see that that was specified in the docs, but I did not enable it. So we'll do that, and we'll do features equals JSON. JSON. This can be why, even if you think you know the APIs, it's useful to read the docs. So let me get rid of a couple of these because I don't need all of that. This is a future, so let's keep the JSON here, I suppose. So .json, because that's what we're expecting, right? And then this is a future again. And we know it's a future because it says impl future right here. And it says that when we're debugging, or when we're using the debug macro to print out the debug formatted JSON response, that type is an impl future. And impl futures are things that we can await. Same thing right here where we're awaiting this actual get request because it needs to go do some work and then give us control back, basically. So that's how I knew this was a future. That's how I knew I needed to await it. So if we await it, we should get a different error, which will be await is not, of course it's not a method call. Yes, it's a keyword. So await is a postfix keyword, not a method call. That makes total sense. Error decoding response body, invalid type map, expected unit at line 1, invalid type map, expected unit at line 1. So what I was expecting is to have to do this. Let me just see. Oh, okay. Yeah. 404 on Beijing. That doesn't sound right. Okay. So what happened here was because I didn't provide a type to JSON, which it kind of needs, it tried to infer the type. And when it inferred the type, I think it got it from debug. And the type, if inferred that way, is unit. So it says expected unit. Expected unit is the type. The type of unit is this double paren up here. It's the type we're returning down here as a value. So it was like we wrote this instead, which is not what we want. We want start.json value here for the moment anyway. So we got a 404 for Beijing. I believe that is because we aren't using the API token at the moment. So we do need to fetch that. We can use standard env, and then up here I will let token equal env arg AQI token, because I think that's what I have set. This can fail, so we'll add a question mark on the end. Envar, not envarg. Envarg would be for CLI stuff, and it would be args because of how that's handled. So we actually do need the query string here already, I believe, because I think if I remember the documentation, that's how this was set up. So we will pass in an array here of, I think it's an array. Let me go check the request docs for query. This is in the response. So let's go back to request builder and let's look up query. Query is somewhere in here. So modify the query string, yada, yada, yada. This method does not support serializing a single key value pair. Instead of using .query key val, use a sequence. So we can't use a tuple here. We have to use like an array or a vec or something like that. Which is totally fine. It's also possible to serialize structs and maps into a key value pair. We don't really need anything complicated. All we are going to do here is take a reference to an array that's called token and takes a token, and it's a tuple on the inside. So we have to wrap this whole thing in a tuple, and then that should give us a valid response. So if you don't have your, oh, well, that also did not work. Let me debug out token to make sure we're getting it. I'm just going to cut this part out of the video. So I debugged out token here. You can see that I took a reference because we're also using it down here. And if we don't take a shared reference to token when we pass it to debug, the token will move into the debug call, which we don't want. But it is there. So something else is wrong. And Beijing is the example in the docs. So I think it's something I'm doing wrong. Well, if you tell me if that hurts a lot, that hurts a lot. So if you are following along and you got the error that we just got before, which is a 404 on this request, make sure that you have the slash at the end. The slash at the end really, really matters. So we were actually passing in our token. Everything was fine. We just didn't have this slash at the end. So yay. Programming can sometimes be frustrating. Okay, so we can get a request for a specific place. There is a second URL that we can use for searching, and that's api.waki.info/search instead of /feed/station. So I think when we do our CLI here, we'll be able to get either a specific place and more info, or you'll be able to search for more stuff. So let's get that in here, I think. So StructOpt, well, yeah, opt is usually what this is called. We're going to derive StructOpt, which I believe we're going to have to actually import. Use StructOpt. StructOpt. Okay, so now we have StructOpt here. We will have to do opt, or let args equal opt, capital O opt from wait, which things are here? I think it's from args that we want. I think this can fail. Maybe it can't fail. So we're good. So we have args. Args is going to be all of these things that we passed in. I'm going to move this below AQI token because we're actually going to get rid of this AQI token call in a second because we need the token for everything, right? So in here, we're going to have opt. I'm going to name this like API token or something like that. Make it a string. We need to use a field level attribute macro here. So it'll be called StructOpt. And we could make this passable via the CLI, like as a flag. I think that we will do that actually. So short equals T, because otherwise it would be T. Long equals API token, right? Or maybe it should just be token. Let's make it token. And then env equals API token, or AQI token. So now we've got an opt struct, right? That has this attribute macro on it that looks kind of, I don't know, I guess it's intimidating, right? And we have one field, which is an API token that's a string. And we've derived this StructOpt derived macro on this opt struct. If you wondered where the name StructOpt came from, it's from StructOpt. So we can get rid of this envar now because args.api token will be, we'll fetch it from the environment variable if it exists for us. So args.api token, and this should all work as it did before because the environment variable is still set. It did. Wonderful. So now we've got this way to set up sort of like additional arguments that we need for our CLI. And the next thing that I think we're going to do is set up a subcommand. So I'm going to name this command, and it'll be, actually, I'm going to name this opt, I think. I'm going to name this AQI, and this will be AQI, and this will be opt. And we'll have a second struct here called StructOpt. It won't be a struct, actually. It'll be an enum opt. Up here, like StructOpt is very heavy on the attribute macros. So we do need to use those again. In this case, what we're doing is basically telling StructOpt to treat this field as a set of subcommands for our whole thing here. Why is this complaining? StructOpt needs to have the derived macro on it as well. So what we end up with here is basically these are global options or global flags or global whatevers. In this case, this is an API token, right? So we get a API token. Specifically, we have it set in the environment. You can also set it inline as the -t flag. So like we could do AQI -t and then like our token or something like that, or -- token and then our token or whatever. But really what we want here is AQI info Beijing and AQI search like whatever, like San Francisco, because that's where I am right now. So in this opt here, we're going to have an info and a search, and we will mostly set this stuff up later. So we're going to come back to this and we're going to add some more fields onto info and search. This is very much like an option type or a result type or something like that. Basically, we have this opt enum that can be one of two values. It can either be an info value or a search value. And one of the really nice things about Rust enums is that we can attach data to them. So basically these can be like substructs if you want to think of them that way. But it either is an info or a search. So they're mutually exclusive, which means that we can use it as the basis for our subcommands. So if we have the args here, right, and we've instantiated a new client, let's say match args.command, right? So this is going to be the subcommand. I could have called that subcommand. I didn't. And then we're just going to go like this, right? Or that's going to blow up in our faces. Why did that blow up in our faces? Oh, right, because I don't have a semicolon here. That is one of the reasons it blew up in our faces. There are multiple. Let's see what's up. I believe that I messed up. Well, I definitely messed up something. What do we have here? Syntax wise. Let response equals. Oh, I'm not matching on anything. Let me pull this back out for a second. So what we need in here, and Rust Analyzer can write this for us, is actually opt info and opt search. So we need to match on the two subcommands to know what to do. And if it's opt info, then we're going to make this request. And if it's opt search, then we're going to make a slightly different request. And this is going to be search and the search token. Let's see. Do we have the API docs here? JSON API search stations by name. Where's the search API? Our online API documentation. Map queries search. There we go. So we need to name it keyword. So we have our token. Our token is already in. We need a keyword. We don't need to deal with JSONP. We're not using JavaScript. So this needs to be a second tuple where the first element is keyword. And we'll do, I'm going to put San Francisco here because we don't have the option coming in yet. This does need to be a full string, maybe? Yeah, it does. So string from San Francisco. And then we've got basically when we search, we hit this search endpoint with our token and a keyword. In this case, I've hard coded it, but we'll get that from the CLI in a second. We're getting back a Saturday JSON value because we don't really know what the return values are yet. And if we're being honest, the return values for this API are not actually well documented. So I know there are things here that look like documentation, but if I remember correctly from using this in the past, not all the fields exist, and you can see that there are no actual, there's no marker about whether these are required or optional. So some of the keys might not exist. But this is roughly the data that we can expect back. So if we cargo run, we are going to need to use -- so that any options that we pass in actually go to the command line application rather than cargo itself. So if we search, then what we get back here is hopefully a list of, country US, San Francisco, of Albuquerque, New Mexico. Not the one I was looking for, but it is the San Francisco. So San Francisco, New Mexico. I assume that San Francisco, California is in here somewhere. That would make sense. But you can see that we have some of these IDs. These actually can go straight into the URLs. So if we wanted to actually search and then select one and then use that as the next request right here, as the path segment where Beijing is, we could do that. And I think we actually will. There is a library that we can use for that. That is a Rust crate called Skim. I've never used Skim before, so we're gonna take a look at that together. But let's get this a little bit. Let's print out some of this. Let's say, what do we have here? Let's start with info. So info here. Well, I'm trying to think about what the easiest way to do this is, because if we search and we get this, it doesn't look great. Let's do this. Let's do toString or Serde JSON. There's a Serde JSON toString function that takes a string reference or takes a reference to the value. And when we run this, we'll actually get a JSON dump here instead of, I'm debugging it. I need to print line it. I need to print line it because otherwise we get all this escaping and I don't want the escaping. Doesn't implement string. Why is this? Oh, okay. Serde JSON toString actually can fail. So that's why the display formatter is not implemented for it, because the display formatter, as opposed to the debug formatter, is not implemented for result or error. I forget which one. Doesn't really matter for us. But now we can actually see there's a bunch of JSON here. And if I want to be super neato, I can just pipe this around because I'm using new shell. So I'll get data and we can just play around with this a little bit. Let's do first 4 because I hit 4 instead of 5. And then we can see that we have the AQI or the air quality and the station inside of the data. Let's pivot this so we can see a couple of the, so we've got AQI, station, time, and UID. So we're probably going to drop time and UID. We'll keep AQI and then we'll have station. Let's see, station has to offer. So station has the country, the geo, the name, and the URL. So I think we can get something reasonable out of this for now. And then come back later and do kind of a prettier output for it. So what did I say we had here? We have data and then station is the interesting one, AQI. So AQI and station. So let's start building a struct here. What I'm going to do is struct search response, something like that, where search response has data, which is going to be a station AQI. Station AQI, does that make sense? Let's do struct station AQI. Has an AQI field that is like a U32. I think this only goes up to 500, so we could do like a U16. But I also have a feeling that dealing with different numbers will be easier. And we're not really worried about space here. So station here will be a station, and then a struct station will be, actually, you know what? Let's cut it off there. And let's say that this is a Serde JSON value instead. So we need to now derive, deserialize, which I don't think we've imported yet or brought into scope, not imported. So at the top here, we have Serde, and then it'll be deserialize, and we are not using standard env anymore. Did I make a mistake in using that? Search. Oh, you know why we can't find the macro? I always forget to turn features on. I swear it's the one thing that it's my huge downfall when working with Rust. I basically always forget. I think this is derive. So if we use derive there, then we can derive deserialize for our two structs here. And then if we take search response, I believe search response can be our new return value as long as this doesn't break. Okay, cool. So let's make that a search response. I don't think we haven't implemented serialize. So this code that we have here won't work anymore because we're serializing the whole thing here, right? So let's do this for station in response.data, right? Did I do that correctly? I didn't do that correctly. I don't think I defined data correctly. There's going to be a vec of station AQIs. So for station and station.response.data, then we're going to print line this and do station.aqi. And then we'll just get rid of this for the moment. We already kind of know what we're dealing with here. So if we get a bunch of AQIs, then we did something good. If we didn't, like this, then we did something bad. You know what the problem is here? The problem is that the AQI is not actually an integer when it comes back from this API. And I'm not sure why it's why it's not an integer, because I think this number doesn't really get that high. It only goes from like 0 to 500 or something like that. Ooh, it's a string because we can have dashes. So this is another thing about this data set. It's kind of messy. So when they say they are going to give us a string, it's actually because they are doing things like this and giving us like dashes instead of numbers, which is fine. This at least gives us a list of stuff. So stations, I think stations have names. But for the moment, I think that I am going to be tired of writing out more structs. So I'm going to do station dot, what is it? Station dot name dot as string dot unwrap. So hopefully, I didn't access this correctly. So there we go. We need to access it like that because it is a Saturday JSON value, and we are getting the name field off of that. And we're getting the name field as a string because otherwise it's just another Saturday JSON value. Because Saturday JSON value, the thing that we're using here, includes strings, arrays, objects, everything that's valid as JSON top level keys. So we have to specify what type we want it as, which is part of the reason that we're defining these structs in the first place, because getting a Saturday JSON value here is really for when we really don't know what we're going to get. And we kind of do know what we're going to get here, at least for the stuff that we care about, right? We do know that there's going to be a data if it's successful. We do know that there's going to be an AQI for basically all of these, even if we don't have one. And we know that the station is always going to be here with a name and a URL. So I'll probably actually keep that going. Let's do struct station name string URL string. I can't think of anything else that was in there that we cared about. And we'll derive, if I can type, we'll derive deserialize. So we're just making it so that we have more stuff available, basically. And then this will be station. We'll have the name and the URL available, and it will be obvious. So we won't need to do this as string anymore, and we can do dot name here. And we don't need to unwrap, because if it's not there, then it's invalid, which Saturday now takes care of. So let's do, how are we going to do this? How do we want to do this? Let's do this here, and we'll do station.station.url as like another line underneath. We will do, do these all come in as 2-digit numbers? Are we just lucky like that? I do kind of want this to be table-ish, but we're not working on it being pretty yet. We're just working on it. So let's do a little bit of padding in the formatting string. So Rust format padding. I forget what exactly the thing is here. It's like, yeah. Okay. So this is 0 padding. I think that this might be the character that we want to pad with. There's a bunch of different formatting like stuff we can use. So yeah, we can pad this to 2 spaces by using :2, which gives us a little bit more of a table output, I suppose. The other thing that I do is if I was going to keep consuming this, I could put a tab in there, and that would work really well for new shell. But I think that's good for now for us. Let's do a new line here as well. That new line is intentional. Let's just give it a little bit of breathing room. So now we have the AQI for a particular station that we've searched for. We've searched for San Francisco, Arkansas Street, wherever that is. San Francisco, California. This is the URL that we would have to use. So we can sort of like, if we know what we're doing, we can look at the URL and be like, yeah, I wanted the one in Mexico, or something like that. The one at the airport, the Toluca. So that's good for search for now. I think we'll use skim here later to actually let you select one, to like search for a station somewhere and then select it and then use it. So we need to get Beijing in here to be an actual user type. So I'm just going to format this string, and I'm going to use the display formatter. And right in here, I'm going to, what are we going to call this? Args. Let me just do this as Beijing for the moment. So we can format this string using the format macro. format macro lets us place these braces, these curly braces, wherever we want this variable to go into. And that should work if we do info. We don't have the nice output like we have for search, so we will need to actually take care of that. Let's do the same thing we did before and do the kind of like pretty printed output, right? So let's make this that. Let's do Saturday JSON toString, the response. We don't have an actual type here yet, so it's all good. We'll print line it, and that will give us, well, it won't give us because I messed something up. Right. I did the same thing we did before where I didn't use the question mark. I'll go run info, and now we have all of that. So let's do from JSON, and I will say data or status. So we have data again. Get data will give us the data. Let's pivot this to see a couple of the actual column names. So we've got AQI for Beijing, the attributions, the city, something called debug, something called dominant pol, which I think is dominant polluter. So PM25 is a chemical. The forecast, which could be interesting for us. The IAQI, which I don't actually know, the index and the time. I don't know what IAQI is. I wonder if we can find that in the docs. So IAQI is the measurement time information. This is the city station feed. Is this the right? So it looks like that'll give us keys and values. So this would be a hash map. Okay, so we've got our response here. We've got a data field. We've got the AQI, which is going to be important. We've got the forecast, which we can use at some point. So let's pull in the forecast. Let's say we've got not a search response here now, but and we'll pull in derive too. Not a search response, but an info response where the data is a vec. Not a vec, actually. The data is a station info. And we're going to get derive in here again, serialize, struct station info, which will be AQI, which I assume is a string again. Let's get the attributions in here because that seems like a good thing to have. Like, where is this information coming from, right? Or like, who should we thank for this? Both of those sides of it. I guess there's like, if there's more attributions, maybe it's more trustworthy. I don't know where those attributions come from. City. Do we want city? What's in city? We want forecast. I think that's maybe IAQI, which I will make a new thing. Maybe I won't make this a new thing. You know, I think that Saturday JSON value gives us what we want for IAQI, because one thing that I do know about this data set is that the IAQI and these chemicals, as we can see even right here, we have 10 results for this in our current query, but we only have one here. So we have PM25 with a value of 71, and the forecast may or may not be there. It depends on whether the station keeps that data or not, I believe. So we may get like PM25 longer term data, but we may not. It may be missing days, for example. Let's see. We get city, name, URL, geo. So maybe we pull the name out of city. We've got the AQI, the air quality is the main thing. The attributions, it doesn't show the attributions here. Object EPA attribution for the station. Okay, so it doesn't actually tell us what attributions are. So we're going to leave that as Saturday JSON value because we have to. The forecast will come in. Maybe we'll use that later. Maybe we won't. The IAQI, I don't know what the I stands for. Individual AQI. I got you. So it's the AQI, I assume, is a combination of all of the other chemicals that are around. The IAQI is all of the individual values. So let's pull this in. Let's start using it as the value here for our request. So you can see that JSON is a very generic function. It can deserialize into whatever type we want it to. Let's do for, actually, there's only going to be one, right? So response.data AQI. Let's do let data equals response.data for kicks. We'll do print line, and then we'll have something here, and then the next line will have some stuff. We'll have AQI here, right? So let's do response.data what did we put in here? I already forgot. Response.data oh, I don't have the city in here. We should have the city in here. Let's do city. I'm going to make it a capital C city. I'm going to put a derive here. They serialize the struct city will have name, which is a string, and we don't care about the other fields right now. Did I mess up a comma somewhere? Why is it yelling at me all of a sudden? I missed like a parenthesis or something here. Did I not finish this? I did not finish this. There we go. .city.name, and then data.aqi, right? Let's get the response out of here. Data.city.name, data.aqi. Let's get rid of this and let's run it. Cargo run -- info to get the subcommand. Error decoding response body integer 59. Okay, so expected a string. The only thing that we are expecting a string for that could be a number is the AQI. So the AQI in one of our requests is a string, and in the other one is a number. So be aware of that if you're using different URLs from this data set. The types for the same name change based on where you're looking for it. It's a pretty great example, though, for a real world use case. So we've got Beijing of an AQI of 59. I think that we can keep this for the moment, right? So we do args up here for our CLI args. For info, we need a URL is what we need, right? We need the URL and we need it to be a string. So I guess we make that positional. And a positional argument, as you'll see in a second, is the ability for us to just, let's see, data.aqi, and then we don't need more there. We need this up here. So we need args. What is it? Args dot, I need Rust analyzer. Oh, you know what the problem is? I need to destructure it here. The URL. So I'm going to go URL here. And it's really not URL. I guess it's a slug, right? So like this slash needs to be there, which is really unfortunate. So let's do URL.trim start matches /.trim end matches / and that should give us like if somebody does /San Francisco / this will protect us, and we can then just put that in right here. One other thing we could do if we wanted to is turn this URL into a slug. There's a library called Inflector on crates.io that would let us do like two kebab case. So we could basically slugify that. Actually, let's do that. Let's do two kebab case because I kind of want to be able to write that. Inflector. And we need to bring in the trait because it's an extension trait. Inflector. Did I mess up? I think that Rust Analyzer just didn't realize that it's here yet. But StructOpt should give us an error because we didn't pass in. Yeah. So now we get this really nice error here that's like the following required arguments were not provided. URL. And then because we use StructOpt, so one of the really nice things about StructOpt and using like a clap or StructOpt or something like that is that we get AQI token info URL. So URL is a positional argument here. So we can do like San Francisco. And because we're doing Inflector, it translates that into San-Francisco, all lowercase, which means that we get the San Francisco in San Francisco, California, which is the one that I was looking for because that's where I am. So we could do other things like if we only have one word, we can do Italy or whatnot. That'll just give us like kind of a random place in Italy, right? If we search for Italy, I wonder which one it gave us. Oh, right. We didn't implement that yet. So let's do that. Let's implement search. This will be search for, let's not call it query. Let's call it search or terms, which is a string. And then down here, we will destructure that. So opt search on this enum, we get to call terms, and terms will be here, and we just get to pass it in. So like before, we're passing something in for keyword here, but in this case, it's just we're passing in whatever the user gave us. So if I search for Italy, it should give me a readout, and I probably I didn't get that one. Which one did I get? One of these is probably just called Italy. I wonder if it just gives me like a match. I think it was one of the. So this isn't something that we did. This is something that the API is doing. So we could stick it in here if we wanted to, right? Like URL city. Oh, that's not what I wanted to do. URL data.city.url. And then up here, all we have to really do is say there is a URL here. And because there is one, we can run this with Italy again and see which URL we actually were getting. And it is actually the one. I don't think that one exist when we search Italy. Does it? Nope, it's this one. Yeah, okay. So is it that one? No, it's not that one. I can't even find it. I don't know where it is. I don't know why the API is giving us a different result here. But maybe it's just kind of like picking one. But now we have some output. We have output for info. We have output for search. Okay, so there's plenty of stuff to do here, right? Like, let's restart Rust Analyzer because I don't like looking at red squiggly lines. So we have search, right? We can search for Italy. Let's search for, I don't know, London, something like that. Gives us a bunch of London results. Let's do info, and let's pick this one specifically, which hilariously is not actually anywhere near London. It's in New Hampshire. Unknown station. So this URL actually doesn't work for that. So if we just look for London, then we get the city of London, and the AQI in London is 85. So that's that. We have search for London, and we also have London itself. So there is plenty more that we could actually do here. The episode is getting a bit long, so I think I'm going to cut it there. But I am going to turn this into a course, and we are going to do things like add a little bit more color to this. Like, it would be really nice if this color here showed as green if everything was good, and red if everything was really bad, etc. And thanks for hanging out for another Let's Code. Maybe I'll work on this again next week. Maybe I won't. If you have an opinion, let me know on Twitter. Let me know in the comments, and I will see you in the next video.